In this video, we will review the second example of how to find an exponential regression. We have the population of the United States from 18,000 till 1860, and the population is in million. If you look at the table, you see that you have years. You never type years on your calculator. You have to change years to T. So it will be 0 years since 18th century. From 18 till 1810, there are 10 years. Between 1820 and 1800 is 20 years. Here we will have 30 years, 40, 50, and 60. Now we are ready to type our table on the calculator. Okay, press Stat, turn the calculator on, Stat, edit, press Enter, go up, clear, down, to the left, up, clear, down. And we will type 0, 10, 20, 30, 40, 50, 60. And check your data. Looks good. Go to the right and type the second column. And again, it's a good idea to go and check if I type the data correctly. For example, right here, the last data, it's supposed to be 31.44. Now everything looks good. We will press Stat again, move to the right, and go down to 0. 0 is an exponential regression. Press Enter, Enter, and we have y equal to a times b to the power x. We'll look at a. A is 5.337. You need to round your initial value to 3 decimal places. And b is your factor, that is 1.0298. This number is a little bit tricky because we have 9 in the third place and we have 8 after 9, so we have to add 1, and it will be 1.030. So b is 1.030, and the equation is 5.337 times 1.030 to the power x. Let's look at this equation one more time. I will press second y equal to Enter, and I will press Enter one more time. Now I want to choose a good window. My t starts from 0 and goes to 60, so x minimum is 0, and 70 is above 60, so I will keep 70. My y starts from 5, so if I say my y minimum is 0, it will be good. And my y goes up to 31, so I will choose 35, something greater than 31. Graph. What do we see? We see the points from our table. Now we'll press y equal to clear whatever you had before and type the equation of the exponential regression that you just found. Like this, and press graph. And you see that it's a really good exponential regression. It goes almost through all the points or close to all the points. This is what we call a regression. Regression is a line that goes closely to all the points. Now we need to answer the question: when the population reach 32 million. And maybe it's a good idea to rewrite this equation. As usual, we use in chapter 4 n equal to p times a to the t power. So n equal, my initial value is 5.337 and my factor is 1.030 to the power t. N is our population. So 32 million people is my N. So I have to substitute 32 for N. To the power T. We see that this equation is an exponential equation because my variable t is an exponent. And to solve this equation, I have to have the base to the exponent on one side. It means I have to get rid of this number of 5.337. Again, to solve any equation, you have to do opposite. If we have multiplication here, we have to divide by 5.337. So it will cancel out here. And you remember, whatever you do to one side of the equation, you have to do exactly the same to the other side of the equation. Okay, let's calculate. 32 divided by 5.337. We got 5.995877834 is equal to 1.030 to the power t. Now we have the base to the exponent on one side. And we know that exponents and logarithms are opposite. So let's use it. We will use a logarithm to both sides. So you see, the only things I did, I wrote a logarithm in front of each side and put whatever I have on the left inside of parentheses and put whatever I had on the right inside of parentheses. The next step, we will use the exponent in front of the logarithm. And this equation is not an exponential equation anymore. It's a linear equation because we can type logarithm of this number on our calculator and calculate it. And we can type logarithm of this number on a calculator and calculate the value. So it's a linear equation, and to have t by itself on one side, again, we have to divide by logarithm of 1.03 because we have multiplication here. So this will cancel out, and we have to do the same to the other side. So let's calculate logarithm of 5.995877834 divide by logarithm of 1.030, and the answer is 60.59353,119. The question is when. So we found t, and t is the number of years since 1800. So we will add 1800, and it will be 1860.59. So actually it will happen in 1861, and this will be your final answer.